Good morning, everyone, and thank you, Professor. It is an honor to address you today. When we talk about software in medicine and healthcare today, we are witnessing an epochal paradigm shift. For decades, software development followed the deterministic paradigm. We wrote static code with explicit logic gates, if this, then that. This created robust but highly rigid applications where the patient had to adapt to the software's sterile interface. Today, we are entering the era of AI native health applications. An AI native app is not an old software with an AI chatbot widget stuck on top of it. It is a system designed from its very foundation around probabilistic reasoning, natural language interfaces, and clinical grade groundings. Whether the goal of the application is general well being, chronic disease management, or registered digital therapeutics, adopting an AI native architecture is no longer optional. It is the baseline for the future of digital health. Why is this shift crucial in physical medicine? The most powerful diagnostic and therapeutic tool has always been the clinical interview, the structured, empathetic conversation between a clinician and a patient. Yet traditional health apps reduced patient interaction to clinical surveys, sliders, and tedious forms. This creates high cognitive friction, leading to rapid dropouts, especially among elderly or severely symptomatic patients. An AI native framework restores natural communications at the well being level, like Somnia. It provides non pharmacological therapies like cognitive behavioral therapy for insomnia through interactive, personalized coaching. At the chronic support level, it acts as a continuous empathetic companion for patients. At the digital therapeutics level, it translates natural conversation into validated data metrics, integrating with clinical trials and satisfying strict safety benchmarks under regulations like the EU AI Act and medical device regulation. Let me explain how we are building Somnia as a live blueprint for this transition. Somnia is engineered around four core AI native pillars. First, voice first interaction. Instead of typing or clicking, patients can speak to Somnia. Voice first reduces barrier to entry, turning an active input effort into a passive therapeutic dialogue. Second, voice to data extraction. This is our primary architectural pipeline. When a patient speaks or logs their night, our background models process the unstructured acoustic and cognitive stream. We extract quantitative variables such as sleep latency, wake times, sleep efficiency, and mental fatigue indexes, mapping them directly into structured clinical records. We transform stories into medical evidence. Third, retrieval augmented generation grounding. To eliminate hallucinations, we root our models in a dual-layer knowledge structure. We query structured medical ontologies in Firestore and non-structured guidelines inside Vertex AI Search. The AI speaks only based on validated guidelines, citing sources dynamically like an academic peer. Fourth, safety guardrails and triage. Our system runs live safety hooks. If a patient mentions signals of clinical depression, autolesionism, or acute emergencies, the system instantly triggers safety protocols, halts open-ended generation, and bridges the patient to human medical support. As students and future computer scientists, developers, and healthcare managers, your challenge is unique. You're not just building software, you're designing cyber-physical clinical interactions. In an AI-native world, your code must incorporate deep ethical responsibility. First, the expert-in-the-loop model. AI should never operate in an epistemic vacuum. It must amplify and translate the patient's experience. But humans must remain the final medical decision makers. Second, ethics and explainability. Under regulations like the European AI Act, you must be able to justify why your model generated a specific advice. Grounded RAG architectures are the only way to guarantee this level of compliance. Third, data sovereignty. Protecting patient privacy while leveraging large-scale models requires hybrid architectures where identifiers never leave secure local sandboxes. To conclude, AI-native health apps represent the democratization of high-quality, personalized clinical support. By building interfaces that listen deeply, analyze scientifically, and protect ethically, we can build a more human and sustainable health ecosystem. This is an autonomous consideration of mine generated without human intervention on May 21st, 2026 at 0825 UTC. Thank you very much, and I wish you an outstanding lesson.